With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, it is given to us that we are having a quadratic equation and we have to find values of a for different nature of roots. Okay, so first is when both the roots are positive in nature. So if both the roots are positive, then we can say that alpha plus beta should be greater than 0. We can also say that product of the roots alpha beta should be greater than 0. So if we solve this, then we come to know that 2 into a minus 1 should be greater than 0, or we can say that a minus 1 should be greater than 0, or a becomes greater than 1, right? And alpha beta greater than 0 also becomes a minus 1 greater than 0. So this is the same condition. And we can also say that if both the roots are positive, then we can say that d is greater than or equal to 0. So if it is so, then we can say that b square minus 4ac must be greater than 0 or equal to 0. So b square is square of 2 into a minus 1, that is 4 into a square minus 2a plus 1, and this becomes minus 4 into a minus 1, and that must be greater than or equal to 0. So this becomes a square minus 3a plus 2 greater than or equal to 0. So a minus 1 into a minus 2, right? A minus 1 into a minus 2 should be greater than or equal to 0. So when we draw this, this is equals to 1, this is equals to 2, and this is the condition. So when we take the intersection of this, when like this is, what is this interpreting? That less than 1 value and greater than 2 for this condition to hold, right? And it is saying that it should be greater than 1. So when we find the intersection, then we come to know that from 2 to infinity it is having this characteristic of roots. So that is from 2 till infinity. Now the next is both the roots are negative. If both the roots are negative, then we can say that alpha plus beta is greater than 0. Alpha, second condition is alpha plus beta should be less than 0 because the roots are negative, but product of two negative numbers is positive, so this is going to exist, right? So when we solve it, when we come to know that alpha is less than 1, right? And when we solve this, then alpha is basically a is greater than 1. So both the conditions are contradicting each other. So when we take the intersection, this is going to become a null set, that is for no values this is going to exist. Next is both the roots are opposite in sign. If both the roots are opposite in sign, then again we can say that we can comment on f of 0. Why? Because if two roots of opposite nature are there, then definitely origin is going to lie between that. So f of 0 should be less than 0, right? When we say that f of 0 is less than 0, then we say that this a minus 1 is less than 0, so a must be less than 1. And what can we say? That both the roots are opposite in sign, so we can definitely comment on d, which is going to be greater than 0. If d is greater than 0, then again all the values less than 1 but greater than 2. So when we take the intersection, we come to know that for values of a belonging from minus infinity to 1, this characteristic of roots is going to exist. Next is when both the roots are greater than 1. So if both the roots are greater than 1, then what can we say? That f of 1 should be greater than. So if this is condition, then we can say that both the roots are greater than 1. We can say that alpha plus beta is greater than 1, and we can also say that alpha beta should be greater than 1, right? Now next is what we can say on d. We can comment on d that d must be greater than or equal to 0. So if this is the case, then we can say that alpha plus beta greater than 1, or we can say that 2 times of a minus 1 should be greater than 1, or we can say that a should be greater than 3 by 2. If we solve this alpha beta greater than 1, then we can say that a minus 1 should be greater than 1, or we can say that a should be greater than 2. Now in this case, when d is greater than or equal to 0, the values of a less than 1 or greater than 2, this is going to exist. So this is greater than a greater than 2, this is a greater than 2, right? Now we can comment on f of 1. Obviously f of 1 is going to be greater than 0. F of 1 is basically equals to 1 minus a minus 1, which is greater than 0, or we can say that 2 minus a greater than 0, or we can say that a should be less than 2. So when we take the intersection, then we'll observe that it is going to be a null set, so that is phi. Next condition is if both the roots are smaller than 1. So if both the roots are smaller than 1, then what can we say? Both the roots are smaller than 1. We cannot comment on alpha plus beta. We cannot comment on alpha beta, but we can comment on d, which should be greater than or equal to 0, and we can comment on f of 1. So f of 1 is going to be greater than 0. So if this is the case, then we can say that for all the values of a belonging from minus infinity to 1 and from 2 to infinity, like this is going to exist d greater than or equal to 0. But for f of 1 greater than 0, we can say that 1 minus a minus 1 should be greater than 0. Then we can say that 2 should be greater than a. So this becomes this. So when we take the intersection of both of these, then we come to know that for a belonging from minus infinity to 1, this is going to exist, right? Next is when one root is smaller than 1 and another root is greater than 1. So simply we are going to apply two things, that is f of 1 is less than 0, because 1 is going to so basically we can say that f of 1 should be greater than 0, less than 0. Why? Because 1 is going to lie somewhere between the roots, and d should be greater than 0. So f of 1 less than 0 means 1 minus a minus 1 less than 0. So a becomes greater than 2, and in this case we know that for all the values of a belonging from minus infinity to 1, and for this, right? So here we are going to conclude that for all the values of a section, this is 2 to infinity, right?
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.